microphone on. It would help if I turned the microphone on for the sound test. Everything seems to be in order. Good! Alright, I'll see you guys in 3 minutes' time. There! Ha! Hello, everybody! Oh, I'm clipping my mic quite substantially. Alright, let me just try adjusting the gain a little bit. Hello! Hello! 1, 2, 3. Yep, that's about as loud as I'm gonna get. Alright, folks. Anyway. Good morning. I hope everybody's doing well this morning. Ooh, did I actually put the slides up on the content? I don't think I did. I finished them this morning, so it is possible that I just didn't. Alright, let me just throw those up there quickly for you guys, and we will get underway with topic number 3 as soon as we are finished with the topic that we were doing before. There we go. However, yes. Or we were further than that, certainly. Yeah. Yeah, okay. So, before we get into that, though, I think that it is important that I talk to you guys about a particular issue that has cropped up with respect to the assignments for this course. So, some of you will have been attempting the assignments over the last couple of days. I've been seeing a lot of traffic on Piazza asking questions about basically things along the lines of, this standard library function, which really should work, doesn't seem to work, and I try it in other programming environments and it works, and it just really seems like Jupyter is broken. And it is with a heavy heart and much consternation and deliberation about possible futures, I agree that Jupyter really seems to not be working with respect to these functions. So the problem, as I see it, is not endemic to the Jupyter system itself, but rather to the C kernel. And this might seem like a bit of a pedantic point, but it isn't. So this is a problem that you sometimes run into when you are relying on open source software. Sometimes open source software is well supported and works pretty well, and sometimes it does not. We have run into a situation where your poor, humble professor was under the impression that a particular plugin for Jupyter would work because it was reasonably old, had a number of, scanf is, POW doesn't work and scanf doesn't work, and that's like the tip of the iceberg with respect to the kind of crap I've been dealing with, let me tell you. This is how I thought things would go. I thought, oh, well, it hasn't really been tested for use with the NB grader tool, which is the subsystem. Oh, what the heck? Is this still working? I hit a button I should not have hit. There we go. Are we still here? Sorry, if you can see this, I'm sorry about this. Let me just pull this back up. What? No, stop. Stop. Technical problems aplenty, I tell you. Sometimes I wonder if it's even worth it. This is... No. No. Stop it. This one. Good. Okay. I'm sorry, I hit some sort of weird button. So, what was I saying? Oh yeah, Jupyter is completely crap and busted, and it's a problem. So, I'm currently working on the solution to the problem. So let me just elucidate. Let me elucidate some of the issues that I've been having with it, to sort of contextualize some of the issues that you guys have been having with it. I thought a certain amount of work would have to be done in order to make the C kernel submissions work with the auto grading software, with Form Grader. If you the problem is that it didn't, and I did the stuff that I thought was necessary, and then it still didn't work because of a similar issue to the basically the what is it? Scanf, yeah. The scanf function, like that reads from standard input. The problem that I'm having is that standard error isn't hooked up correctly somehow, even though standard error messages are displayed. So, because the auto-grading software relies on it monitors standard error, sees if the program writes anything into standard error, takes that as a failed test case, and that's how the autograder works. But if standard error isn't hooked up, then it can't do anything like that. My goodness. So there are a couple of issues, so the current idea that I'm having with respect to this whole thing is there are certain advantages to the Jupyter format, despite the fact that the C kernel isn't working. So when we collect the assignments from Jupyter, like they're put nicely into folders that are very searchable, and it would be reasonably easy to adapt the current model to the Jupyter model, especially considering basically right now I'm sitting with half of an autograder. I have re-implemented half of Jupyter's autograder system, and I'm kind of like at this point I wouldn't say quite ideologically committed to the idea of continuing to use Jupyter, but let's just say that if I were to start accepting submissions in different formats, then that would start, like, the fact that Jupyter standardizes everything into a JSON is extremely useful, and like it means that I can look up the answers to your questions from a script by their cell IDs, which is useful, which, you know, for looking into the future with possible future auto-grading implementation. But I'm not even sure that I can get auto-grading working in this particular course at this particular time. It's like, it's just a tall order. It's a tall order considering all the slides are being redone at the same time. You know, I've only got so many hours in the day, and, you know, I don't know, maybe I can convince one of the TAs to do something about it. But, like, essentially the fallback position at the moment is we fall back to manually grading everything. We'll see if submission of Jupyter files is a thing that we want to take a look at. But, yeah. If you're having trouble loading Jupyter, please follow the troubleshooting outline that's on the first page of the syllabus. Thank you for your note of sympathy. Well, like, the problem with this is that it has implications, right? We had designated weekly assignments, and the idea that we had, like, that idea of having weekly assignments with fast feedback for you guys was predicated on the idea that we have some sort of functional auto-grading system, right? So, like, when you have auto-grading, we can return to you, you know, the amount of time it takes us to process all of the grades and get everything together and get you guys your feedback is a matter of days because everything is automated. If TAs are doing it, they have, you know, you're starting to talk about people who have schedules, who can only work so many hours a day, and who have other things that they have to do too. So that lengthens out the amount of time that it takes to get any marking accomplished by like a factor of 5 at least. So, you know, if it is the case that I have to walk away from the idea of auto-grading, I'm probably going to have to re-examine the frequency of the assignments and maybe even the frequency of the tests as well. Again, I'm not trying to worry you guys, you know, like, please understand that in the end everything will work out, and maybe you'll have fewer tests, and that might even be a good thing. But, like, right now, right now I'm just looking at the whole system and I'm like, the amount of work that's necessary to get this working is not trivial, and it might be too much to ask of a poor, humble sessional professor who's also trying to defend his thesis this semester to not only like come up with all new lecture slides, which, takes me about, oh my goodness, each slide that I present I think takes somewhere in the vicinity on average of 15 minutes to produce, so I can make about 4 slides an hour, which, given the fact that the slides are on average, 50 slides, it's about 2 days, right, of work per day, or work per week just to make the slides, and, that doesn't leave a lot of time for, trying to get an, re-implement Jupyter's autograder from scratch. Yeah, so, we're going to take a look at it. I'm not convinced that I still don't like Jupyter as a distribution system. In terms of, sending you guys assignments and receiving assignments back, it's not too bad of a system. As a server, it has certain advantages over Avenue. But, yeah, that's where things are right now. So, I've already got an extra TA than I was allotted for this course. Yeah, it's... Eclipse. Submissions through GitHub. It could probably be made to work for sure. Yeah. Yeah, that's possible. Probably not a lot of you are super hip to Git just yet, but hacker rank. I'm going to write that name down. Yeah. Yeah, so this is a thing that I've been seeing is hackathons, hackathons / programming competitions seem to have these types of things built into them sometimes. But, yeah. Yeah, thank you. Thank you for your wishing me good luck on my thesis. So, yeah, basically, it just means that less can be done if auto-grading doesn't work, which means, generally speaking, I think that the way to create a good course is not to have a bunch of fancy stuff going on. I don't even necessarily think that auto-grading makes a good course. It's the secondary knock-on effects of auto-grading that make the course a good course. For me, it's all about the base stats. Harvard Online, GitHub, yeah, okay. How much time it takes for you guys to get feedback on your assignments. I see that as a critical issue, and if we can't get auto-grading working, then that's going to take a considerable hit, and I think that's a bad thing overall, but, at the same time, there is only so much that we can do, But I am certainly going to be putting some people on it, seeing what we can come up with. But, so, let me tell you how we're going to handle the rest of Assignment 1. And I will also post this to Avenue in case somebody misses this on the lecture. But for now, this is how I would like you to do Assignment 1. Continue to use the Jupyter system for filling out and submitting your assignment, but run your code somewhere else. Which is horrible to say, because that's kind of supposed to be the whole point of Jupyter. But if you could write your code in some other format, you can use the code templates that are provided in the Jupyter assignment. Just take that somewhere else, write your code, then put it back into Jupyter, and submit your code through Jupyter. Or at the very least, in the form of a Jupyter notebook. Yeah, trust me, there is no troubleshooting for Jupyter, just some documents that aren't very well explained. So that's how we'll proceed for now. And, it'll be what it'll be. Anyway. Oh, yeah, that's what you're talking about. The troubleshooting for getting into Jupyter is on the first page of the syllabus. Can you assume that if it runs on Jupyter, it'll work somewhere else? Yes, I think so. However, it's kind of like running on Jupyter is a subset of all of the C programs that work. So if it works there, then it'll work elsewhere. But any suggestions on another program to use instead of Jupyter? VS Code is a good, VS Code is a good one. For sure, VS Code is a good one. I use VS Code for personal projects, so I recommend it. You can also just use a text editor and, invoke GCC in the sort of regular, If you're wondering about how to do that kind of stuff, check out the tutorials from the previous week. See, I'm not completely stupid. I was hedging. I didn't realize it at the time, but I was hedging my bets with those tutorials. Anyway, so let's talk. Let's get back into the lecture material, just so that we can get back into it. Windows has its own version of the C compiler. I'm not sure what it's called or whether it's currently compatible with the current spec. If it isn't, it doesn't matter. The C code that we're learning is essentially the C. It has essentially been the same C code for 20 plus years, so it doesn't really matter what version you're using. So, we were talking about loops. We were talking about the difference between for loops and in Python versus C. So in Python, for loops are used to iterate over the elements of a data structure. So if you have a dictionary and you want to loop over every entry in the dictionary, you use a for loop. That's what they do in Python. In C, for loops are just syntactic sugar for the most common loop structure. So if you notice in the previous slide, for a do-while loop, we've got the initialization statement, the body statement, the update statement, and the condition. In this, we just put our initializer, our condition, and our update inside of the braces, round braces that immediately follow the declaration of a for loop, and then you put your body statements inside of the body, as you might expect. So, for example, for int I is equal to 10, I is greater than or equal to 0, I minus minus, printf, etc., etc. So, for loops kind of serve one or two purposes primarily. Number one, it's a readability thing. So you don't have to go hunting through the code for all of the things that affect the loop execution, like the number of times the loop executes. That's all that information is in one place, which can be very useful, especially if your for loop is something that occupies more than a screen's worth of code, which is definitely a possibility in C. It is not a compact language. The other angle why you might want to consider using for loops is because you are required to put the initializer, condition, and update all up front, you won't forget the update statement. I would estimate that probably 95% of cases of infinite loops are caused by somebody forgetting the update statement. I am one of the worst offenders when it comes to this. I forget my update statements all the time. So using a for loop statement like that, or using a for loop in that manner, will make your code slightly less horrible to deal with. I'm just going to take a look at the comments. Yes. Is the Jupyter C kernel from the course outline broken, or just the one from you connect with the student VPN? They are the same kernel and both broken. I think there might be a version of it that's not broken, or less broken, but at this point, like, if it's not reliable software, I'm looking for alternatives to it rather than updates to it, you know? Blech. Anyway. So, continue, and, you can see that I had intended this for the last slide of, like, a lecture, but, you know, so it goes. Two statements may be used to control loop execution outside of the loop's main conditional statement. Break exits a loop. Doesn't matter what type of loop it is, it exits it. When the program pointer hits a break statement, the top-level loop the program is iterating is immediately terminated, as if its conditional test had returned false. This can go in the middle of the body, though, which makes it interesting. Break can be very useful for programs with complex logic. The truth literal can even be used as a loop conditional if the program breaks correctly. So, for example, you could imagine... Oh, that's a Python interpreter. Gross. Who uses Python, am I right? You could imagine... I'm just going to put this in a function. You could imagine a while true, although we'd have to be using standard Boolean. There we go. While true if something, then break. There you go. That's equivalent in terms of its constructional complexity to just, you know, setting that as the loop condition. There's a comic here that uses breaks. Yeah, there you go. Etc. So, there we go. Continue starts the next iteration of the loop. So it's like you ignore the rest of the loop and you jump back to the beginning of it. Of course, jumping back to the beginning of it has different implications depending on whether you are in a while loop or a do-while loop. But in any event, continue jumps back to it jumps immediately to the next iteration of the loop. These are not quite so commonly used. Most people use if branching to not execute some code rather than using a continue statement. Continue kind of begins to look a lot like a goto statement, which is universally despised. Continue can reduce the indentation level of your code if you are the type of person who is inclined to care about how far your code has been indented. And to be fair, like at a certain point, you know, if you're dealing with like 7, 8, or 9 tab characters over, then that starts to get a little bit, you know, but, you know, white space doesn't actually matter in C, so you don't have to use a tab character to indent at all. In fact, 2 spaces is often used. 2 spaces is often used for indentation rather than a full tab character. Let's see. That's true. What did I say that broke every first-year Eng student's heart? I don't know. I can't remember. Anyway, break is also used in switch case blocks, but we already talked about that. So, last slide, comic, although I guess this is technically a meme. I'll zoom in on it so that you guys can actually see it. There you go. Oop. It's me writing good code for once, but it's actually Stack Overflow. There you go. Hopefully that's funny. I thought it was funny. Okay, anyway, so that's topic 2. So we're now officially... We're actually making pretty good time. Lots of people use Python. It's just snobby people don't like to admit they use Python because it's too easy. Programming should be harder than Python, which is, you know, why we beat ourselves senseless with things like C. Yeah. Also, generally speaking, there's a bit of an animosity between the Python people and, like, everyone else, because the Python people think they're better than everybody else because their language is, like, it's superiorly, like, they have the superiority advantage in terms of language organization, and everybody else is like, uh-huh, yeah, you think so? And part of the reason they get to continue to maintain their smug arrogance is because Python, like, whenever anybody else comes up with anything good, they steal it. So, you know. Anyway. Anywho. Let's talk about functions. Functions, library, architecture, and recursion in C. So, you may think to yourself upon reading that title, I already know what a function is, therefore I have no need to pay attention this week. However, you would be very mistaken. What we're going to be talking about primarily here is like your computer's subsystems, how the computer is organized, rather than, like, obviously it, like, the syntax of how to declare it. Well, you can see it. The syntax of how to declare functions is covered in 5 slides. All the rest of this through here, this is all architecture stuff, and then at the end we've got a little bit on recursion. Recursion is not a major topic in this course. I do not believe that recursion is a major topic for mechatronics people in general. Not nearly, like, you guys don't tend to be as, like, mathematical abstraction based as, you know, the comp sci people, for example. But then again, the comp sci people have a dedicated course in first year of learning the Haskell programming language, and Haskell doesn't even have loops. It uses recursion for everything. So, incidentally, Haskell is a wonderful programming language and really is the superior programming language to all other programming languages. Anyway, so let's talk about functions. We're going to talk about the grammar of functions, header files, library files, and the existential plight of humanity. Functions, how do they really work? An example of the call stack, storage classes, scoping, and a few other things, and recursion. Gonna check for questions. Okay. So, functions are the basic unit of abstraction in C. This means that when you want to do code abstraction, functions are what you're going to be using in C. That and structs, but structs are kind of a different thing, and we'll get to them in a later topic. Not yet. Later. Functions are highly similar to how Python implements functions. However, there are some important differences, not all of which are syntactic. The return type of the function must be indicated where Python uses the def keyword. In the absence of a return type declaration, GCC will give a warning, and the return type will default to int. Oh, there's the mailman. Our mailman is cool. I like our mailman. Anyway, Curly braces are used instead of a colon and indentation, as you will have seen quite a bit in C so far. The arguments must also have their types declared. So this is an interesting difference between Python, because in Python, everything is dynamically typed, right? It doesn't act... The data type that things are is inferred from usage, right? Whereas in C, C wants to know up front what you think the data type is. And if you aren't using your data type the way that you've declared that you're using your data type, that will cause warnings in the compiler. In C, everything comes down, like, the main concern with data types in C is how many bits am I supposed to be moving around here? You gotta at least give me that. I already said that. While a return statement is not required, GCC will complain if one is not present. I'm going to look it up. What is my favorite programming language? It depends for what application. I like Haskell for its semantic elegance. I like C because of its groundedness. I like Python for doing stuff that I wouldn't want to do in any other language. And I like C# for game development. But that's mostly because I use Unity. Anyway, so here's the difference between Python and C in terms of syntax. We have this max function, takes x and y and returns whichever of them is greater, and x if they're both the same. Or sorry, y if they're both the same. So you can see def is replaced by int. Int has to be declared here and here. There you go. You'll find as you go along that many other languages follow this convention. Even languages that you might not expect, things like Verilog, which is roughly C-based syntax, but don't let that fool you guys. When you get into third year and start doing FPGA languages, when they say the syntax is based on C, that means nothing about the semantic. Absolutely precisely zero about the semantic, so be warned. FPGAs are probably the most difficult programming language that you guys are going to have to deal with during this degree of yours. So, here are some what the warnings might look like if you have written your function poorly. If we comment out the return statements, we get the problem, warning, control reaches end of non-void function. If we omit the typing information here, warning, type of y defaults to int, type of x defaults to int. So if you don't specify anything, it'll just assume integer, which is different from Python fundamentally. Python will try to figure out what the type of the argument is from the manner in which it's used. But C is just like, it's probably an integer. Same thing if you do not specify the return type. There you go. Questions? Are there void type functions in C? I believe so. Yeah. Let's try it. Void. Doop doop doop. Doop doop doop. Wait, I have a code library here. Alright. We'll just modify this one. Void. Do nothing. Now, let's attempt to compile this. GCC, do I need to, yeah, no I don't. GCC, top.c, top, oop, that doesn't work, top, there. Nope, yep, void is legal. To answer your question, void is legal. Computer languages are better than people. Well, I wouldn't say that computer languages are better than people, because people are actually quite interesting if you get to know them. However, computer languages are definitely superior to human languages. It is impossible to have the same sort of vagaries that people usually have in their, natural language is what we call it. You'll hear the term natural language when you start taking courses on requirements and that sort of thing. Natural language is terrible for writing math. It's not bad if you're Shakespeare, though. So, here's a new thing for you guys, function prototypes. In C, as in Python, in order to use a function, it must be in order for a function to be in scope, it must be defined before it's used. In the previous example, if the function max was defined before main, then it's in scope, but if it's defined after main, then it's not in scope. GCC will produce the following warning. Warning, implicit declaration of function max. Did you mean main? In, some line in main. Early versions of C did not check for correct function usage at compile time, so the error would show up at runtime instead. Function prototypes solve the issue of having function typing information available while maintaining C's back compatibility with programs written before static function checking was added to the standard. This is why this is a warning and not an error. So, in essence, let me demonstrate. Let's say do nothing actually printed nothing. Right? Sure. Let's say that we called it here. That's no nothing, but okay. That's fine. Oh, is this top? Yeah, top.c. Okay. Doop, boop, doop. No warning, and it would execute. However, if we put this down here, oh, did I save it? I didn't save it. Try again. There we go. We have warnings. Implicit declaration of no nothing. Conflicting types, even. That's because the implicit declaration would have assumed things to be integers, but we have declared them to be voids. That's problematic. So the way that you get around that, if you want to be able to put your functions anywhere you please, is by adding a function prototype. So there is a difference between definition and declaration. This is a declaration of a function. This is a definition of a function. If we put our function prototypes basically right underneath the include statements, then they're valid for the entire file. And incidentally, this business of you getting warnings if things aren't declared in the correct order, that can apply when functions are calling other functions as well. And if, I don't necessarily recommend having circular function calls, but if you have, things that call each other in some sort of, going back and forth, which is totally conceptually possible, you will have to just deal with those warnings and things that maybe not working out correctly unless you put in your function prototypes. So, just to demonstrate that that works, ta-da! With the prototype, everything works out. That's because the compiler is told by this what the typing information is. So, it can, figure out what everything does. Anyway, questions? Why would you want to do this instead of just defining the function first? So, there are a couple of reasons. A couple of reasons that we're going to see a bit later on that are related to header files. But let's imagine that we had two functions with no prototypes. Function A and void B. Sure. something like that. Let's say that A called B and B called A. And let's assume that, you know, we were intelligent enough to put some sort of conditional into these things so that they don't loop back and forth infinitely, right? Which one of these do you put first? Neither of them, right? One is dependent on the other. That's why the only way to be able to do that correctly is to use the function prototypes to declare ahead of time that A and B are both functions that exist with typing information. So hopefully that's an answer to your question. Do you need to declare the type of the function of both the definition and the declaration? Actually, that's a good question. Let's see. Well, let's see if we get any warnings on this first. Oh yeah, that doesn't exist anymore, so we will definitely get a warning on that. Burp. No warnings. Good. So, let's see if we can't delete this information successfully. Ha! So, C is not that intelligent. My corona. So, if you leave off the typing information, GCC will say implicitly int, regardless as to whether it already has a definition. It does not refer to the previous definition, so you do have to include the typing information each time that it's written. You do. Ha! That should, like, that right there should give you an impression for, like, the flavor of C as a language. You learn C's rules. C doesn't learn your rules. Yeah, void means that it returns nothing. Task failed successfully. Ha! Yes. Good. So, there you go. Anyway, so that's function prototypes. That's why you would use them, and in how you would use them. Oh, and then this slide also tells you stuff about them. So, function prototypes are actually a construct that C has borrowed from C++. Quite some time ago, though. A function prototype is syntactically the first line of a function declaration terminated by a semicolon. It is good practice to put function prototypes immediately after your preprocessor commands, if you're going to use them, including that's the include statements, etc. This declares the function up front, so its definition may now occur anywhere in the file without generating any warnings. In fact, it doesn't even need to occur in the file. This is the cool part, which we're going to get into when we talk about headers, actually very, very quickly. So, the interesting thing about function prototypes is that you don't even necessarily need to include the function definition in the same file as the declaration. Wait, did I say declaration twice? Definition, declaration. No, I'm good. Okay. They can be in different files. As long as those files have been given to the compiler, it'll be able to figure out. All you have to do is include the header file, and the header file doesn't even need to include the file that contains the definitions necessarily, or the declarations, or no, the definitions. Anyway. So let's talk about library architecture. That's basically what I was just talking about, was library architecture. So, computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of computer systems, from Wikipedia. And this, if any of you are not familiar with this, this is the Minecraft library. It's kind of a cool thing that exists these days. People from all over the world can view pieces of journalism and literature which have been banned by their local tyrannical governments within the context of the Minecraft library, because it's like it exists inside of a loophole, which is kind of cool. But anyway, I have a second thought about this, which is it's a shame that all of our generation's best architects are doing everything in Minecraft instead of real life. Because that is a beautiful building to me. I really like that building. Anyway, void just means void is it just means nothing. Returns nothing is a good way to think about it. Anyway, header files versus library files. Things that are useful. The ability to call functions defined outside of a source code file. That's useful. The ability to pre-compile functions. That's useful. The ability to share library functions among many programs. That's also useful. These purposes are served by the library system. Because a lot of your operating system, kind of irrespective of what operating system you're using, a lot of your operating system is probably going to be written in C unless you're using a pretty exotic one. This library architecture is actually the way that most major operating systems use libraries. So this might be interesting to you. So, you've got two primary components, header files and libraries. The header file contains the prototypes of functions made available by a specific library. Notice, so header files have the .h file extension, and libraries have the .c file extension. The header files are linked to the libraries. Libraries are files in which the functions specified in the header file are implemented. There are two main types of libraries, static and dynamic, which we'll talk about. Because their functionality is so closely linked, when a person says a library, generally speaking, they are referring to both the library and the header file taken in combination. So if you'll notice, when we write a C program and we are making reference to some standard library, we are making reference to the header file. We aren't doing stdio.c now, are we? That's an important distinction. There you go. Questions? Or no? Okay. So, this will be our last slide for today. Static versus dynamic libraries. Static, the word is derived from the Greek statikos, meaning causing to stand. In a static library, static libraries contain object code linked with a program, which is then integrated into the executable. They are included upfront at compile time. This is the distinction, but one of the major distinctions between static and dynamic libraries is that the static ones are included in the executable upfront, whereas dynamic libraries are the functions that are linked to, if they're dynamic libraries, are loaded at runtime. There are interesting and cool implications of that. Anyway, consequentially, the compiler needs to be able to find this library. If it's a static library, the compiler has to have that library at compile time. Whereas, if you have a dynamic, so the word dynamic is also derived from the Greek dynamikos, meaning powerful. So, dynamic libraries are linked to the executable at compile time, but the implementation of that linked function is loaded at runtime. That's the difference. These, you have to have the whole thing up front because it is hard-coded into the executable itself. Whereas, in dynamic libraries, you hard-code a link to an external function, and that function is loaded into memory at runtime, not compile time. this is very, very cool and useful. The linking resolves undefined references in the source file, and this means that dynamic libraries not only may be, they may not only be linked to a large number of programs from like one compiled source, but that library may be changed, updated. You know, you can download your updates and it'll update without having to affect the executables that use it, as long as the interface remains the same. And that's super, super, super important. Imagine if you had to recompile every program on your computer every time one of the library files was updated. That would be computer hell. You would be doing nothing except compiling programs, and that would be the entirety of your computer's existence, especially given the frequency with which things are updated these days. So that's, however, you know, static libraries do have their place. In particular, generally speaking, when it's a system library that you're going after, dynamic is better, and if you're, you know, writing your own libraries for your own projects, static is usually good enough. You don't necessarily have to go to the trouble of making it a dynamic library. Anyway, I'm just going to answer any questions that you have, and I think that'll wrap it up for today. Looks like we do not have any questions for at the moment, but probably we'll have a couple sort of filtering in over time. Yeah, thank you very much for your time and attention, folks. Again, I am sorry about the issues that we're having with Jupyter. These are kind of the types of growing pains that you often see when you're trying stuff for the first time. We'll just have to handle this like the bosses that we are. That's all I'm going to say about that. Anyway, thank you very much for your time and attention, folks, and we'll see you in the next one. Eh?